Alright, gonna make this quick one here. This is for 3.5. I believe that's where we're at. 3.5, and this is derivatives with trig functions. And this really is going to come down to just memorizing some stuff. Okay, these are the 6 trig functions that we are going to be working with, and you'll need to memorize what the derivatives are for each one and how to use them. So let me just talk about this in general here first. So here we go. This is my, I hope we know this, sine graph. Sine starts at 0, 0, has a period of 2 pi, and it looks something like this. Now I guess what I want us to think a little bit about here is the slopes of this, because when we're talking derivatives, we're talking slopes. Here at the peaks and the valleys, we should have slopes of 0. So I would guess that the derivative would be a 0 here, a 0 here, and a 0 here, and so on. If I'm thinking slope, this is looking very positive to me because it's going up. And this is looking very negative to me because it's going down. So I would think positive slopes, positive values here, and negative values here. Well, if I tap on this, it should show me a graph of that derivative. I think it will. Nope, I probably have to go here. And like magic, there it is. Let me lose that. So let's take a look here. 0 corresponds with a 0. 0 slope corresponds with a 0 slope. Positive going up. Positive values above the x-axis. Negative going down. Negative values below the x-axis. We're going to talk lots more about graphs here very soon. But for now, I think it's good to just kind of get an idea as to what's going on. Now the big idea here is this red one should look familiar. Not sure if you recognize it right off the bat, but that is my cosine graph. Starts at 1, goes down to -1, period of 2 pi, and that is a relationship that is very important. The derivative of sine is cosine, and the rest of the slopes or derivatives work off of that idea, and instead of graphing them all, we're just going to memorize them. So here is a list of 3 of the derivatives you need to memorize. Next page I have the other 3, but you need to just memorize these, know them inside and out, make flashcards, do whatever you need. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. Those are the 3 biggies, and then the other 3 are derivative of cosecant is negative cosecant cotangent, derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. I would write these in your notes, I would make flashcards, I would memorize them. Let me do a couple of examples. Here we go. Y equals x squared sine x, find dy dx. Of course, there's going to be a little twist on these. The twist here is I'm going to have to use product rule. Derivative of the first times the second plus, and here's where the new stuff kicks in, derivative of the second times the first. I think I'll do a little bit of a rewrite here. It's a good idea to throw the coefficients or whatever you have in front of the trig function. Just looks nicer. Combine if you can. We can't, so we're done. Next one. So let's try another one here. This one I'm going to have to use quotient rule. Derivative of the top times the bottom minus derivative of the bottom. Sine is cosine, but there's a negative there. So that's going to give me a negative cosine, which is going to make this a plus cosine times the top over the bottom squared. And let's do some simplifying here. I'm going to distribute here, boom and boom, and I'm going to get negative sine x plus sine squared multiply here, plus cosine squared over 1 minus sine x squared. Now, I'm not sure if you remember your Algebra 2 trig days, but this is an identity. Sine squared plus cosine squared equals 1. So this leaves me with negative sine x plus 1 over 1 minus sine x squared. I think I can do a little bit more because of a little bit of rearranging here makes this 1 minus sine x. This is a 1 minus sine x. This will cancel with one of those, and it will leave me with this. So as you can see, we need to know our new trig rules, but we also need to apply them to the rules we've already been using. Quotient rule, product rule, and stuff like that. So we'll practice these in class, and please let me know if you have questions, and see ya.